recording. All right, good afternoon, good evening, and welcome to the Minnesota Elementary STEM CTL, an Engineering by Design overview. My name is Ryan Novitsky. I am the STEM CTL Director of Learning.
Hello, I am Darcy Jones, the STEM CTL Director of Innovation.
And I am Steve Barbado, Executive Director and CEO of ITEEA.
And you'll hear from me. I'm Mike Sandell, Director of the Consortium Director for the Minnesota Engineering by Design.
And we have two overarching objectives for today: to analyze engineering by design overall, as well as overviewing STEM CTL initiatives. On our agenda for today, we have an introductory to engineering by design. What is it and what is it all about? A presentation on the standards for technological and engineering literacy, or acronym STEL, navigating the media-rich edition, MRE, and standard edition, SE, of engineering by design courses, specifically the audience being elementary school educators, media-rich edition for all, STEM Center for Teaching and Learning Initiatives, question comments, and a report out by your state consortium director. At any point in time, if you have any questions or comments as we're going through the presentation, please feel free to utilize the parking lot that is linked within the presentation right here, or if I left click on the parking lot, I can also be able to navigate right there. If you do not have access to the presentation, I will take 1 second this time to place it into the chat. That way you will have access to the presentation as we go through it with all the applicable resources that accompany it. All right, so, well, what is it? We're all here for engineering by design. We've heard about it, we've talked about it, but what is it overall? It's a program that is built on the belief that the ingenuity of children is untapped, unrealized potential that, when properly motivated, will lead to the next generation of technologists, innovators, designers, and engineers. Before going in and specifically talking about the individual overall what EBD is about, I wanted to mention our sequence of learning and the K-12 standards-based core. You'll notice that there's pre-K2 all the way to 12th grade, in which we have curricula that are designed from pre-K all the way to 12th graders. This is not to say that you need to take one course before taking the other. It is recommended that you take a Foundations of Technology course prior to technological design. It is highly recommended. But if you don't, it is not to say you cannot be successful in one of those courses. Specifically for elementary, for the EBD TEEMS Next Generation, same thing. If you do not take the EBD TEEMS grades 4, that does not mean you will not be successful if you take EBD TEEMS grades 5. It is highly recommended because they do build upon one another with the content, pedagogy, and lessons. When I left click over here on the bit.ly link, and it goes directly to, well, what is engineering by design overall? Engineering by design is integrative STEM education, all the curricula that can operationally be defined as the application of technological and engineering design-based pedagogical approaches to intentionally teach content and practices of science and mathematics education through the content and practices of technology and engineering education. Integrative STEM education is equally applicable at the natural intersections of learning within the continuum of content areas, educational environments, and academic levels. We are composed of 4 different areas for our EBD consortium: curriculum, assessment, professional development, and research. We are a research-based curriculum, which means that research drives every single one of the curriculums that is made and implemented with engineering by design. We are standards-based models. So the standards for technological literacy, engineering literacy, the NGSS, Common Core standards, all help to drive our curricula. In the media-rich edition, which we're going to highlight in a few more minutes after the presentation of STEL, we're going to talk about how engineering by design uses assessments in order to drive instruction. And most specifically, We use pre and post assessments as well as other diagnostics that can be embedded within our LMS or learning management system that helps to analyze students actively being in your classroom. We offer professional development. So very similarly to right now, for Minnesota, we hold workshops over weekends, we hold 4-day institutes, and we hold many different opportunities such as conferences, seminars, and a lot of other professional development opportunities offered online and person to person, depending on situations. As mentioned before, we are standards-based models. So we have our engineering habits of mind, the next generation science standards, Common Core state standards, and the standards for technological and engineering literacy. You'll notice also when my cursor turns into the hand, it is hyperlinked and goes to the resources as well too. We discussed the core in regards to the sequence of learning from pre-K to 12. EBD teams, if it says 1 to 6 weeks, what that's referring to is that there's many lessons that are within each grade level. And if you were to teach them all within a given time, it would take approximately 6 weeks to go through and cover. And the same things for EBD teams next gen 6th grade capstone, 3 to 6. It takes about 6 weeks. But then you see exploring technology. Exploring technology is most readily used or most frequently used in schools that are 6 to 8 and is more so adopted as a 6th grade course. And takes about a semester to teach as well too, over the course of 18 weeks. Today, specifically, we'll be showing lessons from grade 3, grades 4, as well as exploring technology in a little while. There's additional middle school curricula as well too. Our Engineering for All, that is vertical farming, Engineering for All water, the world in crisis, in which these are enrichments. And Engineering by Design, each individual lesson, each individual learning cycle is based around our 6E lesson plan model. We have engage, explore, explain, little e, engineer, enrich, and evaluate. Let me backtrack a second. When we focus on, when we say the little e engineer, what we're actually focusing on is this. We are not saying, for instance, that if a student takes our courses, they are going to only be allowed and only take the course if they should be an engineer. We are trying to gear the students with the arsenals of having critical thinking, problem-solving skills to help them to understand a certain problem or topic by applying concepts, practices, and attitudes, and application portion of it afterwards. Engineering by Design is not a concrete model that only develops towards one spectrum of students. It is a curriculum for all. Our media-rich edition has an online assessment portal in which there are pre-assessments and post-assessments that are delivered. The pre-assessments are given at the beginning of the year, and once given at the beginning of the year, the educator is enabled to see how many students reached a particular standard by missing or answering a question properly. For instance, if STEL 1 had a person answer a question properly, it'll show that. But if it had a question answered also improperly, it also show that, because our assessment questions are driven through the standards. And for diagnostic purposes, when they take that post-assessment at the end of the year, it enables to show you the overall growth of your student from beginning to end, as well as being able to use it for a reflective stance for the educator for the forthcoming school year. As you saw above, and I believe on slide 3, we continuously use research to drive our curriculums. Our curriculums are being innovated, revised, and rewritten based upon the students and the students' needs, especially as we're going towards the 21st century with all the technological advancements. We continually use this research to drive our curriculums. For instance, embedding soft robotics into one of our high school courses in 2017-18. Also, our team's grade 6 is going through a revision process right now as well. Software is utilized. We recommend that Tinkercad is downloaded ahead of time because it is utilized in the curriculums, but it's not needed in regards to you have to have it in order to teach the content. If software isn't, if computers aren't always readily available, you can be successful in teaching the class. Whether you're in a classroom setting or a virtual setting, The lessons and the content can be used and innovated to meet the needs of you, the educator, and the students. And now I'm going to pass the baton to Mr. Barbado to present on the standards for technological and engineering literacy.
You got it. To open up the presentation again. I had closed it. I shouldn't have. There we go. One second. There we go. I was trying to figure out a way earlier to shorten it up, and I decided I'm just going to skip a few slides as we go through, and I was trying to play with it a little bit with hidden slides, and I wanted to unhide them. So that's what I was just working on. Sorry. All right. Hit that. Hit that. Now we're up. So the standards for technological literacy are something that came about in the year 2000. But in this presentation, I'm going to be sharing with you a lot of information about the new standards, which are standards for technological and engineering literacy, which were just completed in July of 2020. So as I go through this today, we're going to be talking about how ITEEA provides products, services, and supports for all educators to engage all students through active learning in a design-driven, integrated STEM education classroom. So the standards were produced in July of 2020, and since then we've been putting together a variety of resources on the website, which I'm going to highlight as we go through this process. The importance of technology and engineering is something that has been lacking in our normal school system over the decades. And with this new emphasis that the National Science Foundation and Technical Foundation of America have funded and sponsored, with our efforts, we've put together a program that we think will really launch a new effort to better explain the role of technology and engineering in STEM education. So there are groups out there like the National Assessment of Educational Progress and the NAEP TEL Assessment, Technology and Engineering Literacy Assessment, that's out there that really reinforces what we're trying to do and how we do it. And better yet, students that have the time to go through a program that's following these standards will be better prepared on these national assessments. So we redefine technology and engineering as the ability for these programs to be integrated, design-based, to be making sure that we dot the I's and cross the T's and all the technology and engineering aspects as we go through all the different facets from pre-K through 12. There are 3 dimensions of learning that have been a part of technology and engineering for the past 100 years in our association, and that's knowing, thinking, and doing. And the knowing part is organizing it, understanding it, making sure there are factual as well as conceptual relationships. Thinking, making sense of information through questioning, analysis, decision-making, and doing, using technology and engineering in applied ways. It's also engaging students to make it fun. It's actually creating in STEM education a way to engage students so that they have a way of controlling the world around them. We focus on a small e. What does the small e mean? It means that it's a verb to use engineering design and the application of engineering habits of mind so that students become thinking like engineers. They don't have to be an engineer as a noun, so civil engineer, mechanical engineer, etc. But they need to be able to think like an engineer to be able to cope with the rapidly changing focus of our world. So as we go through, and I'll highlight some of the features of STEL, we have in this octagon, set of 3 octagons, the standards as the core. That's that gold center in the middle. There are 8 core standards for technology and engineering literacy connected to 8 practices. So in the big picture of things, all 8 standards, pre-K 2, 3, 5, 6, 8, 9, 12, for the grade bands need to be taught through the 8 practices that you'll see there. Everything from collaboration, communication, and attention to ethics, to systems thinking, creativity, making and doing, optimism, and critical thinking. So that's a real key. And as we do that, we're going to be connecting them through a variety of contexts. So the standards are those 8 in the center. The red part are the practices. All of those must be taught all the time. And it's done through a variety of different contexts that you drive from your decision making. So as we look at these, we used to have 20 standards in the old standard set, the STLs. We used to have 288 benchmarks. Now we have 8 standards and only 142 benchmarks, much more realistic and doable in today's world. So as we look at these 8 core standards, we have the ability from these to be able to break those out by grade level, as we were talking about, and create benchmarks that must be realistic, but also driven and with a high benchmark. So as we went through this, we decided to make sure that students have both the hard skills, the formal skills, as well as the soft skills that connect to technology and engineering through these practices. The technology and engineering standards and practices are then taught through these contexts. And there's an example on the screen. Brian, if you could, for them, I did not put the link in the Minnesota agenda for today. So that one that I put in the chat is this one, because I did make some edits.
I'll put it in.
To put it in, thank you. So you'll have full access to download this. The domains of learning are connected to the technology and engineering dimensions, but most importantly, we have the student outcomes connected to each one. And we have a lot of references and resources for those. Each of the standards are highlighted with a variety of key ideas, and also it walks the teacher through how, and the educator who's developing the curriculum, what is technology, what is engineering, what is the science, what is the mathematics. And these are all connected as we go through all the way up through grade 12. So in recommendations using STEL, we use an ABCD approach for converting benchmarks to instructional objectives. A is for audience, B for behavior, C for condition, and D for degrees of mastery. So there's an example there as we go through them, and you can reference those. I did a presentation for Illinois the other day, and Darcy helped me do some research on it. But I left this in here for this group because no matter what the context, this one is virtual reality and augmented reality. There are ways to connect it through those contexts to those 8 core standards and the 8 practices, a critical piece. There's some cool resources here as well that are connected to the Caterpillar Foundation and then connected back to our contexts with those 8 areas that are listed there. And then the disciplinary standards connected then with the benchmarks. We also have resources that have all the STEL benchmarks, the Standards for Technological and Engineering Literacy, connected directly to the approved next generation science standards and the Common Core state standards for mathematics and English language arts. So we've already done that homework for everybody, and that's sitting there on our website ready to go. So this is an example, for instance, on STEL core standard number 7, design in technology and engineering education, and the valid matches that go from the STEL to the NGSS to the math to the ELA. And then again, in the different grade levels, this is 9 through 12. We also have then a connection for the cognitive, affective, and psychomotor areas with the verbs, and a connection then to the knowledge of dimension. And that's done for every standard. So they're available for download free. You can have a printable version for a small fee, an EPUB edition, and print version for a small fee as well. We're working real hard right now to continue developing online resources, and one of those is a STEL lesson plan template. We're hoping that everybody can take advantage of this. It's going to have online and fillable areas suitable for all subjects. Efficient writing and alignment with STEL will be the end result. And with that, we're going to be focusing on the 6E model of lesson planning. It's the 5E with an added focus of engineer to apply, conceptualize, inform design, modeling, and create. The lesson plan format then, we're just finishing up right now, and there'll be some examples on the website very soon. but we're hoping that by our spring virtual conference that we'll have a tool ready to go in place for all teachers to use, and a web app as well as a mobile app. So the additional resources that are on the website, benchmark crosswalks, marketing resources, a variety of different research documents. And the deal is we want to make sure that everybody gets into this call to action, that everybody understands what technology is, what engineering is, and more importantly, what it takes to make sure that every student can become technologically and engineering literate. They need to have the ability to understand, use, create, and assess the human designed environment that is the product of technology and engineering activity. Critically important. So help your school system move forward, be a part of understanding what STEL is and how to apply it, share it with your administrators, and also come to the website. We have a Q&A area on there through the Idea Garden that you can ask questions, and feel free to shoot emails to us as well. So there's a download of this in the chat window for this, and it's also connected to the agenda. Let me go back and stop sharing. Okay.
Thank you, Steve.
You bet.
All right, thank you. Now we're going to go on to navigating the media-rich edition and standard edition of our Engineering by Design courses. For the media-rich edition, we are going to highlight 3 different grade levels, 3, 4, and 6. So Darcy is going to be introducing grade 3 and grade 4. I will conclude with exploring technology and then showing the standard edition for exploring technology as well too. So this time I will pass the baton on to Darcy.
Thank you. All right. I hope everyone's seeing the Buzz portal. Is that correct? Okay, good. Thank you. All right. So depending on your network agreement, depending on which course that you register for, this will look a little bit different. To the top right here, we're going to start talking about navigation. You will see under the Choose app that right now I'm in Teacher View, the Teacher app. So this is what you would see depending on which classes you selected and according to your network agreement. You can also preview as a student just to see how it would look from a student perspective. So for the first example, we're going to go through EBD TEEMS grade 3 and specifically lesson 3. So I've noticed educators use a lot of acronyms. So the MRE here is for Media Rich Edition, and TEEMS is actually Technology, Engineering, Environment, Math, and Science. So this is the next gen grade 3. So for navigation, this is the entire landing page for the entire course. So you should see here a variety of resources. There's a breakdown of safety guidelines, videos, resources, and every arrow, if you open it and then collapse it, it allows you to view more within these different features. So there's also a welcome to EBD. This is what Ryan went over at the beginning. The course introduction, this is for the course overview of the entire grade 3 course. So the arrows that you see here, the less than, the greater than, and then back, these are how you can navigate through Buzz. So if you click the next arrow, it will go to next activity. If you click this back arrow, it goes to previous, and then this arrow goes back to the entire course page. So you'll see here, there's lessons 1 down through 20. There's also a pre-assessment and a post-assessment. So the difference between the standard edition and media rich edition is a lot of documentation and data that you get from these assessments. So your students can actually take the assessment within here, and then you are able to keep track of their data that way. You're not doing this on your own. It is available here within the Buzz management system. So for the example, we're going to go through lesson 3. And this is an introduction to the engineering design challenge, specifically apparel or an object design challenge. So each of these lesson breakdowns will have the overview, standards, learning objectives, the 6E lesson plan or the 6E lesson highlights, and a form of assessment. So for this example in the overview, students will be introduced to a design challenge. Students design and engineer a model of clothing, footwear, or other device that reduces the impact of wet weather or a wet weather related hazard. And so all of these overviews, these lessons will have an overview, the big ideas, or the purpose of the lessons, and sometimes you'll see those enduring understandings, the lesson duration, and then the 6E lesson highlights. And so this is an overview of which 6E that it's going to actually include. So from the next activity arrow here, it's going to advance to the next activity within this lesson 3. So again, this is grade 3, lesson 3. These are the standards and benchmarks that pertain to this specific lesson. So one thing that Ryan and Steve both mentioned was we are constantly updating and improving different lessons. So these standards in here are the STLs, and they will now be updated with those new STELs, the standards for technological and engineering literacy. There's also common core standards such as the math, English language, and next generation science. So if we advance to the next activity in our lesson, this is the objectives. And the next lesson, or the activity here for lesson 3, this is the 6E lesson plan. And so in this specific lesson, its focus is on the explore. So not every lesson will have all of the 6 E's, but within those units, there will always be all 6 E's. So in this specific lesson, students will construct their own understanding of clothing and or footwear through the engineering design process. And students will be introduced to the design challenge where they will create a design solution that reduces the impacts of a weather-related hazard by engineering a wet weather, apparel, or gear design. So then it gives the teacher how they should prep and prepare their classroom or lab space. It goes through what exactly the teacher should do for preparation. Here they would need a copy of the design challenge for each team, a step-by-step list of teacher procedures, a list of materials, and then it gives you the materials in the supporting files, an extension. So in this, students could create models or prototypes. You could take the lesson a little bit further until you see fit. So again, with EBD, it really is best interest of the students and the teachers. And then very important, safety and conduct. So if we advance to the next activity within this lesson, this is an example of the supporting file. You can preview it here. You can also use this pop out option, which will open up in a new browser tab. And it's also down here under the attachments with the paperclip. And so I am going to go through another lesson here for Teams grade 4. And just a reminder for navigation, if I were to go to next activity here, I'm still within grade 3. It's going to take me to our assessment, and then it's going to go right into lesson 4. So just to review, this is how you navigate back and forth. And then to go back, we can click the main back arrow to view all lessons. So over here, the little hamburger option, this is the main menu. You can go back to home this way if you have multiple classes you're teaching, and this is where you will see your teacher side. Again, if you want to view it as a student, you can go over here to the 9 dots at the top right and view as a student. And so the next activity we'll look at is a little bit different, especially for the 6E. And this is Teams grade 4. So we're actually going to view lesson 9. So again, you can view everything within these folders by opening the arrow, and then you can collapse it to close things back up. So for lesson 9, this was the greenhouse effect. So all the lessons will have the overview, standards, objectives, the 6E lesson plan, supporting files, and an assessment. And sometimes the assessment might be a rubric. Other times it will be that pre and post data that you're able to see then with the media-rich edition. So in this lesson, the overview is building upon what was learned in the previous lesson about heat and measuring temperatures. Students will investigate how a greenhouse works. Working in small groups, students construct a model of a greenhouse, measure temperature, and observe changes to learn about energy transfer. So all the lessons will go through the big ideas, the purpose of the lessons. Some will include those enduring understandings, the lesson duration, and then the 6E highlights. So if we advance to the next activity, these are the standards and benchmarks. So in this example, there's a few for the STLs. Again, these will be updated to those STELs. The Common Core State Standards for English Language Arts, Next Generation Science Standards, and the Common Core State Standards for Mathematics. Here you will see the learning objectives. And then this is the 6E lesson plan. So the one before was a little bit different. In this lesson, they're focusing more on that engineer with a small e. So students will develop greater depth regarding the greenhouse effect by designing and fabricating a scale model greenhouse, then collecting and analyzing temperature data from the model greenhouse. So in this lesson plan, it will go through the lab and classroom preparation that the teacher will need to do in order to complete this activity with the students. The preparation, so making a copy of the greenhouse experiment, which we'll take a look at in the supplemental supporting files, a step-by-step for procedures. So in this example, it tells the teacher how to introduce this activity. It gives supporting example questions to follow up with students. You have your list of tools and any material and equipment that you may need. Additional resources. Again, very important, safety and conduct. And then an extensions portion. If we go to the next activity, these are the supporting files. Again, you can preview these by clicking and opening. It will open up a new browser extension. You can also open them up in a Word document by the attachments down here at the bottom. And then the next activity would be the assessment. And so this assessment is more of an exit ticket that students can place in their STEM notebooks. And again, since this is the Media Rich edition, they can start within here and actually submit this through. And then I can go ahead and, are you able to see the PDF file? Yes, okay,
Yes.
Thank you. So this is just a real quick example. This was the TEEMS grade 3. This is the standard edition. So it is a PDF file. It does have everything, but that difference here, and maybe, I'm not sure if it lets me preview them side by side, is really this data and the assessments that are built in. Also with the Media Rich edition, you can open up the files really quick in the browser tab or have a Microsoft Word document open as well. But this is what the standard edition looks like. So it still goes down through your big ideas, purpose, lesson duration, the 6E, lesson highlights, and as well as the standards and benchmarks, as well as the prep, procedures, materials needed, extensions, safety and conduct. All right, I feel like I should pause. I know that's a lot. I know it's a lot with the class 9 grader and I'm navigating arrows. And I can pass this off to Ryan, or I can also take time to answer any questions right now.
All right, so now we're gonna go over and show exploring technology. And the reason we chose to do 2 different grade levels in the elementary and then do exploring technology opposed to EBD Team 6 is because it's a little bit different. And how it's a little bit different, and I'll show what is the interface gonna be a little bit different. It's way it's aligned more with the middle school courses for 7th and 8th. But for some schools, they're going to be 6th grade. They may want to use it for a full semester or throughout the course of the year, or they're going to want to integrate lessons throughout the year if they choose to do elementary. So I'm going to show those differences, though, with the Exploring Technology curriculum first. Navigational purposes, If you're a first-time navigator to the EBD Buzz portal, going to go to ita.org, going to left-click on the EBD Buzz. When you left-click on the EBD Buzz, you're going to be prompted to your login area. When you're prompted to your login area, you're going to left-click on Login, and then afterwards, you're going to choose, well, how are you going to navigate it? You're going to navigate it as a teacher, and afterwards, you're going to go down to the course that you're going to be teaching. So if we're looking for Exploring Technology, I'm going to left-click on Exploring Technology, and then I first want to mention what you see right here. You have your Knowledge Skill Builder, or acronym KSB, located right here. So overall, you should see the differences between the EBD TEEMS curriculum or curricula opposed to Exploring Technology. Exploring Technology, I&I, and Tech Systems, the middle school levels, are focused on KSBs, and it's built in this structure and opposed to individual lessons. So when you left click on one of these, you're going to notice it says KSB1 lessons, which is in bed. All these lessons are in bed within that Knowledge Skill Builder. But the interface, the Buzz system, is the same. The drop-down arrows that go to your course descriptions, your safety guidelines and resources, your welcome to EBD that talks about the core program, which we mentioned, your course introductions, as well as your lessons. So for today, we're going to focus on, well, what is Exploring Technology about? Exploring Technology prepares students with an understanding of what technology is, the universal systems model, and opportunities to apply the engineering design process in problem solving. I'm going to backtrack out of there, and I'm going to go to the first 5 days. This is another little difference of the first 5 days in the EBD TEEMS curriculum. Because it is taught over a longer duration, you'll notice that you have different verbiage or words that are used sometimes for the curriculum or content. So when you click on first 5 days, your first 5 days is specifically what you're going to be teaching for those first 5 days of school if you were to be teaching it over the course of a full semester, or even possibly spreading it out throughout the year, depending on the composition of the way your school best needs fit for it. When I left click on the first 5 days, it says day 1. What is continuous through all the curriculums from 6 through 12 is you're going to, typically speaking, have a problem-solving activity on that very first day. The big idea for our first day 1 overview is everyone has the ability to invent, innovate, and improve designs. So this talks about, again, and really goes and hones in on our universal curriculum, where we do try to meet everybody, because this is a curriculum built for all. And one of our main goals is to teach students that anybody can be an inventor, innovator, or a designer. The purpose of this lesson is to engage students in the Exploring Technology course from day 1 while enhancing their technological literacy and their skill set to solve problems and engineer. In essence, you're teaching that student to become a problem solver from the very first day, and you're engaging them in an activity via problem solving. Similarly to EBD TEEMS, but a little bit different, this has a full 6E lesson plan embed for each lesson or each day built within the course overall. You have your engage, explore, explain, engineer, enrich, and evaluate. I'm going to right click a couple times to next activities to show the supporting files. And for the first day of school, for the very first day with your students, they would be doing the design challenge. The design challenge would be a school recycling design challenge overall. The activities are embedded directly within the first day to explain explicitly what you're going to be doing with the students in the first day. In this one, in groups of 2, create a new plan for recycling at your school. The purpose of the first 5 days, especially with day 1, is for the educator to get the students out of their seats, working together, collaborating, and making that strong culture within the classroom, and being able to gauge your students from day 1 on where they are with their problem-solving techniques. Now, I just saw a curriculum for EBD TEEMS grade 3 and 4 and Exploring Technology, which is for grade 6. So how do I get access? Well, when you're on the ITA website, you're going to go to Global STEM and then STEM by state. So left click on STEM by state, and afterwards you're going to go through and say, well, you know, okay, I'm going to choose my state, Minnesota, North Dakota, South Dakota. We're going to choose Minnesota right here. And afterwards, you will left click on accessing EBD curriculum. If you are interested in just trying the Buzz system, you can do that by simply left clicking on request for EBD course review access. And if you are interested in implementing it throughout the whole year, Mr. Sandell will be talking about that shortly as well too, as far as saying how to get access via your consortium. Course outline and course sequence examples. We have a grade 2 and grade 4. Sorry. On grade 2, what I specifically wanted to focus on or kind of highlight overall is the durations. Lesson 1, for instance, says 30 minutes. Lesson 2, 40 minutes. For grade 2, you'll notice all lessons are within that time span of 30 to 60 minutes. And it's fairly similar also when you go to grade 4 and 5 as well too. When you go into exploring technology, it drifts a little bit where it may be more consistent towards those 60 minutes because it is the course of a full semester. If you have a learning management system or an LMS that your county, city, district, or similar wants you to utilize or use, we have a way to make sure that if you want access to the media-rich edition, you are able to take it from our Buzz system and port it over into your learning management system. For instance, if you have Schoology, if you have Canvas, etc., we can take what's currently in our content and via submitting a ticket help request to our Buzz support, they will help you to get it over from your LMS, our LMS, to your LMS. So we'll work with you along the way to ensure that you get access to the media-rich edition. Our STEM CTL, as mentioned before, we have many different professional development initiatives or opportunities, one of them being an authorized trainer institute, which essentially makes you a authorized teacher effectiveness coach, which enables you to deliver trainings for your state once you go through our training. And I'll pass the baton on to Darcy to talk about our next 2 STEM CTL initiatives.
Great. So the STEM CTL really is here to help you and guide you. And so we try to provide a lot of free resources or resources that will help you with professional learning or professional development. So one of the things that you'll view here is the STEM School of Excellence Recognition Program. For ITA non-members, this is $295. For members, it's $195. There's processing criteria through a point breakdown. And so really what this does is it helps get your classroom engaged, your school itself engaged, not necessarily just your classroom. And so if you're a part of the STEM School of Excellence, your school will receive a banner and a certificate for displaying in your school, and the STEM School of Merit will receive a certificate to display in the school. It is linked in here through the application and the processing criteria, but the point breakdown can consist of anything from hosting something in your community or doing a STEM outreach in your community, doing something that will help better someone else that's challenging with something. So there's a variety of different, I think about 30 different criteria that you can hit and achieve points. Next is the REACH Challenge. So through the REACH Challenge, students have the opportunity to use their STEM skills to reach a member of their community who has a challenge to overcome. So focusing on the empathy and user-centered design portions of the engineering design process, students will work with their user expert to identify a specific challenge and design and create a viable adaptive or assistive technological solution to that problem. One of the things that's new for this year is the toolkit. So you do receive a REACH Challenge toolkit to use in your classroom that includes things like lesson plan ideas, activities, other valuable tools, but this year it is virtual. So this is able to be done from a hybrid perspective, or if you are teaching remote, So even if you're teaching online classes new for 2020, there's the design from a distance toolkit. Oh, sorry, apologize. So next up is microbadging. So microbadging are these little mini bite-sized topics. There are two different sessions. There's a digital literacy session and there is a safety session. So each session has 10 different classes. You can take any from 1 to all 10, and each is 1 hour of professional learning. So if you complete all 10, you will receive a micro badging digital badge in your email, and you will receive a certificate. But these are 1 hour of professional development. You can take any of them that you would like, but if you do complete all 10 in safety or all 10 in digital literacy, you will receive that little micro badging graphic for your email and a certificate.
Right. And if you have any other questions or comments on the presentation today for what is Engineering by Design and how we're here to best support you with professional learning and development overall, please feel free to place it in the form. And again, just to do a quick overview, the purpose of today was to show you how to access your curriculum. It's also going to be further explained by your EBD State Consortium Director. What is Engineering by Design? What does it look like? What are the courses? What are some of the courses? And today we focused on exploring technology and EBD teams, grade 4 and 6, navigation and how to find your courses. For instance, EBD teams grade 2, how do you find it within the LMS of Buzz? We also talked about the standard editions and what they look like, how to download them, and also the composition overall. Feel free to utilize the questionnaire we have embedded within our presentation. And now I'm going to pass the baton on to Mr. Mike Sandell to talk about Minnesota.
Hi again, as Ryan said, I'm Mike Sandell. I'm the Minnesota Consortium Director for Engineering by Design. This program is being put together by the Minnesota Technology and Engineering Educators Association, MTEEA, and St. Cloud State University. Right now, the way, as Ryan, in the presentation, as they talked about, the Media Rich edition or the Buzz edition is available, and also the standard or download edition. And then if you have a learning management system, it can be downloaded into that using the common cartridge. If you go to the next slide, because I get to give them all the good news here. So what's the cost for this? Of course, it's not exactly free. For any single level, grade level course, because there is a fee for us to bring this to Minnesota, there then is a licensing fee for this, for you to use this, the Buzz edition or Media Rich edition. For any single level course, it's $200 for the licensing fee plus some training. If you want a pre-K 6 package, so you can do it by building, it's a lot less, $650 per building, $100 per teacher over 4, which we wouldn't reach that because it's a $900 max, plus training involved there. And then the middle school and high school are there, but as this is an elementary presentation, we'll just move forward. Along with purchase of the Media Rich edition, they also have the opportunity for become part of the ITEA STEM school members, which at a cost of $100, which is reduced from the $260 cost. And this gives you access to things like the Elementary STEM Council Journal and all the other membership benefits of MTEEA or ITEEA. Access to the download version or standard version is $100 per person or free to any MTEEA, ITEEA member. Could you go to the next slide, please, Ryan? Ryan, could you go to the next slide, please? I think we lost him. Maybe you lost me.
Go on the next slide.
Mike, can you hear us okay? I think he's frozen.
Oh,
His face isn't moving. Yeah.
I couldn't tell if he was frozen or not.
so
And
I
he's
don't.
gone.
That next slide, I go what?
So
But
we can pick it up from here.
yeah, for trying out EBD Buzz, I did show it a little bit before, but you can always left click on the EBD course review access form. And what's great about this is that when you go through the presentation, you request to use it, you'll be able to go through and use the MRE edition for 2 weeks. And if you need an extension for an extreme circumstance or anything similar, you can always reach out to us individually afterwards and say, I need a little extension because of ABC, and we can work with you the best we possibly can on that extension. Looks like Mike's back, and I'll let him pick up. All right, and in regards to additional information about engineering by design, please feel free to reach out to your state consortium director at any point in time at mn.engineering.by.design@gmail.com, and the phone number is listed there as well too. If your school is interested, please reach out directly to him in regards to any information pertaining to engineering by design. Thank you so much for participating in our presentation on the Minnesota Elementary STEM CTL and Engineering by Design Overview, the first edition, the first presentation. And if you have any questions this time, we are open to questions. It's a limited edition, by the way, LTD.
Yeah, my internet is not being very kind today.
That's all right. It gets
happens.
upset and cutting down your street.
Kristen?
There.
Kristen, do you have any questions? Anything we can help you with more?
Not at this time, thank you.
Okay. I will be sending the link to this recording out in an email probably tomorrow.
Mm-hmm.
Sounds good, guys. Thanks so much.
Thank you, Kristen, for joining us today.
Yeah, thank you so much.
Bye-bye. Thank you.
Thank
Take
you,
care.
and have a good night.
Thank you.